it'll kind of be stuck at first. You just kind of got to wiggle it back and forth until there it goes. The symptoms of this are when you turn the thermostat on, it starts and it heats up and you can hear humming sounds. So that damper opens right back there. So it opens and then you hear flames go woof. Inside of it, it heats up to 180 degrees down here. So the boiler will actually heat up to temperature, which is 180 for fin type radiator systems, where the air has to go through the fins on those like baseboard heaters, you know? So it'll come up to 180 degrees and then it'll shut off because the boiler is only designed to run at up to 180 degrees, because if it hits over 212, it starts to boil and then it turns into a bomb. But it has a safety precaution for that, which is this right over here. This is the pressure relief valve, and if it hits over 30 psi typically, see it says right there, yep, set 30 psi. If it goes over 30 psi, then this trips and it sprays water out to prevent it from actually exploding. Okay. Make sense? Yeah. So consequently, you don't want to ever fill a boiler more than 30 psi when you're filling it from the water source, which it looks like right down there. That looks like the fill valve right there, if I'm not mistaken. This is a reduced pressure valve, and they use those sometimes so you can like leave the water on and then it will like add water if there's like a leak, but that's actually not really allowable anymore. So you just turn that on when you need to add water. Our pressure in the system right now is at about 12 psi. And see on that top one, there's psi on the inside and kilopascals on the outside. See it right there? Right at about 12.
CPA.
Yeah. 10 psi, see the psi on the inside one? Yeah. So we're looking at the inside numbers. 10 psi is enough for a single level house like this. 15 psi for like a 2-story house, okay? Even less than 10 psi would work, but usually we leave it at 10. Sometimes these gauges go bad too, but I think this one is still working. We're going to be really releasing some of the pressure here momentarily. So it'll heat up to 180 degrees. You'll hear a humming sound, but the pipes will never get warm in the house, okay, if the pump is bad, because it's heated up, but the pump is not making the water circulate. Make sense? So those are the symptoms. A lot of times this will get really hot right here, and then what you do is check to see what voltage you have. We did an amp draw test on this last night, and we were drawing like 1.2 amps or something like that, and it's only supposed to draw 0.75 amps, indicating to us that the rotor is stuck inside of that motor. And then you can also kind of hear it hum and feel that it's not turning, because it's not like going to vibrate as much. It'll just be like humming and the motor will be hot. And then the other thing we did is we very carefully removed this wire nut, and then we tested to see if we had 120 volts or 115 volts. This pump is 115 volts, it says right there. 115 volts, 60 hertz. So that's how we diagnosed that the pump was bad. So the only way to fix a pump like this is to get a new pump, because these are not really designed to be serviced in addition to that, unless you're like a super brilliant magician person. So we're going to replace this now. Thankfully there are isolation valves. This is an isolation valve here, so we're going to turn that valve off. And then I think, so that's on the, well, we take a look at the arrow. There's an arrow on here, and the arrow is pointed down. So the arrow is pointing down, so that means this is the return side of the boiler. Make sense?
And
see how this, there's
water running through.
Yep. See, there's an arrow on this new pump as well. So we just want to make sure that that arrow is pointing down when we install that new pump. Okay. So we have this side isolated with our isolation valve, and on this side, unfortunately, it looks like our only isolation valve is on the other side of the pressure tank. So this is our pressure tank here. So we're going to isolate the system right there. And the reason that it's kind of a bummer that the tank is right there is that now we have to drain the pressure out of that tank in order to get this thing down to 0 psi. We're going to drain some pressure out of this boiler drain right here on the side of this boiler. Oh, perfect. So we're just going to release this. Sometimes these things are... There it goes, I think. Oh, maybe I just stripped it out. Yeah, I just stripped it out. Kind of surprised it hasn't started dripping yet. There, it's seated. So we have all the pressure drained out. We can see that our pressure gauge is working because that is all the way bottomed out at 0. So I closed that drain again though because I actually want to lose as little water as possible. So when we take that apart, if that were open, then it would let air in and we could drain the entire boiler, what's inside of it. So we drained just enough water to lower the pressure, and then I closed it again. Make sense? Before you get started with your pump replacement, make sure that you disconnect power and verify that there is no power using an electric meter if possible. So all that's holding this in place, what we'll do is we'll disconnect the wires first. That's very straightforward. In this case, there's not even a ground wire, which is actually kind of a bummer. It'll be fine, but so we just have a hot wire and a neutral, 115 volts. Same as like what a furnace or any other appliance would have. Touch it to make sure it's not live. And then we can just set that to the side. So now our pump is free other than just needing to be disconnected from the system. Grab that bucket right there. Did you hear that? It kind of like sucked air in at first. Mm-hmm. You can just kind of set it underneath that pipe there.
How is that significant?
How is what thing significant?
You said
how it sucked air in. That means that we had the pressure down far enough. So I had drained water out, and since this was a lower point in the system, this was actually in a vacuum, a slight vacuum up here. It doesn't really matter that much, but so those top ones are loosened. Once I start loosening this one, it'll probably start dripping. Voila, it started dripping.
Started running.
Started dripping.
Or stream.
Started streaming.
Dripping.
This is the original streaming.
This is called the live stream here, folks.
Maybe the guy that invented streaming used to be a plumber. It's like, what should we call it when we watch something online? How about streaming? Yeah?
Although they wouldn't.
No?
It's not called streaming unless you're doing it live, right? No? Or is that...
Well, but you can stream a movie, right?
Streamer. Yeah, I guess you're right.
Save these bolts. These bolts look good, but oftentimes these things will go bad. They'll just be super rusty, and so we would replace those if they looked bad, but they don't look bad at all. Alright, so the bottom bolts are out. One cool thing about this setup, with this isolation valve being right there, the only water we're going to lose is the water between that ball valve and the pump and the bottom of this pump. So very small amount of water. It's very awesome because we want to introduce as little air into the rest of the system as we possibly can. Now I'm just kind of steadying the pipe up here, and then it'll kind of be stuck at first. You just kind of got to wiggle it back and forth until there it goes. It's kind of hard to see. But what we'll do is we'll kind of take a screwdriver and scrape these faces of these flanges to get them cleaned up a little bit. Alright, we got those cleaned up. Now we're going to use these standard flange gaskets because it'll work fine with the type of flanges that we're working with here, but in some circumstances you have to use the really large flange gasket. Can you hold this for a second? So here's a larger flange gasket style. So if you have flanges that rotate separately like this, okay, so see this flange that rotates around, sometimes these won't seal properly. Look at that. Would that seal? Absolutely not. So you have to use those larger style gaskets in some circumstances, but these are kind of your standard ones that come with most pumps. All right, so here's our pump. We can see that our arrow right now is facing up. We know that we want that to be facing down, so we'll flip that around the other direction, and then we can set our gasket on top there, and then the bottom gasket's kind of annoying. There is like an indent that gasket has to sit in. So we've got that lined up there on the bottom. I just kind of hold it as we slide it into position, and then lift it up a little bit more. Kind of came out there for a second. All right, now you can set it down. And then even just getting a couple bolts set will generally hold it in place. So we'll get all those bolts started, but we're not going to tighten any of them yet. Is there a reason why we'd want it to face the other direction? I don't think so. I think that's the way it's got to be. But theoretically, you can flip this around either way, but the pump would kind of be in a bad position if we faced the motor towards this control. This gives us more room between the control and the pump, so it's our best option in this situation. I think we will deal with the hydronics first, and then we'll come back and finish the wiring. So we're going to tighten the bottom set of bolts on this pump and leave the top bolts loose. That way we can bleed the air out of this pump as we fill the system. We're going to open this valve right here. Now we should be able to continue adding a little bit of water now. Is there anything leaking out of the pump yet? So right now there's 10 psi of pressure on this bottom side of the pump. There's a check valve that's holding that water down. So no water is leaking up and out of this connection since it's loose. So it's isolated based on the check valve in the pump and this isolation valve right up here. So as soon as we open this, it's going to allow water to go down, and we should be able to fill the pump and bleed the air out of this fitting right here. You see that we've got a little bit of water coming out there. We're going to just let it drip out while we tighten this down. I'm actually going to close this now because I'm confident about the air being out.
Is there some sort of mixture in with the water that's in the system?
I think this system might have a little bit of antifreeze in it.
It doesn't smell. I mean,
Yep, it smells a little bit weird. It's always kind of brown, black, nasty, especially with this type of boiler, which is a cast iron heat exchanger. But the amount of water that we actually lost, or fluid, is about a quart, which is going to be fine for just adding regular water back into the system. But I'm not even for sure if this is antifreeze. It always smells a little bit funny, so that's not a guarantee anyway. So we have these tightened down. What we'll do is wipe this down now and get all of the water off of it. We might tighten these up just a little bit more, but you really just need to let the gaskets do the work. The gaskets don't have to be all the way mashed totally flat. They can still have a little bit of space in between these flange faces. Just tighten them down until they're sealed, and then a little bit more, and that's all you really need to do. So the pressure on our system right now is still a little over 10 psi, so we've got our pressure right where we want it. All right, we're making our electrical connections now. This is just a plastic housing here that we're going to be threading this in. With that, it's best if there's a ground wire that goes to the pump, because there's not a separate ground wire that can attach to our grounding terminal inside of here. But it's going to be fine because our pump is connected to ground through the plumbing system. So we have these steel bolts that are going through from the flange, the steel flange of the pump, to the steel flange of the pipe on both sides, and then ultimately this pipe is connected to ground inside of the boiler. So it'll be fine, but best case scenario is that you have a separate ground wire inside of your conduit. So if you feel extra motivated, you could pull an extra ground wire through to your pump if you need to. I'm going to loosen this like this, and that's going to allow us to just put this in here and thread it in without having to take this coupler loose. We could take the coupler loose if we needed to. Using one of these is better in my opinion, but that's not the way this one's designed. So it's going to just thread into this pump housing. So back in here we have our L, N, and then ground. So line, neutral, and ground. Line is always going to be black, or your hot wire. It could be red, so, or another color even. But we just push our lever down and then stick your wire in, and you can give it kind of a tug to make sure that it's well seated. And then here's our neutral wire. That's always going to be white, or should almost always be white, possibly gray. That one's going to go in the neutral. And it's kind of painful pushing this with your finger, so you can use a screwdriver to push this lever back, and it's more comfortable. Just be careful not to push too hard, or you could break it off. So our line and neutral are both connected there, and we can put the cover onto here. This is a 3-speed pump. It can be a 0.55 amp, 0.66 amp, or 0.75 amp motor, depending on the speed. We're going to set it to 0.75 since that's what the original pump was rated for. You have to kind of get this switch in the correct position in order for the cover to go on. It's got to go over that switch lever. This part is pretty self-explanatory, but you take the Phillips screwdriver, put it on top of the head of the Phillips screw, slowly turn it clockwise until it feels like it is beginning to reach the bottom of the threads. Once it gets stiff, stop turning or you will strip it out. GoPro battery died, so now we're reverting to the phone. So right here you can see we have high, medium, and low. We're going to set that to high since that does correspond with our 0.75 amp setting on our new pump. And right here you can see that our original pump was that 0.75 amps like we were talking about. Before you turn power back onto your system, make sure that you have both of your isolation valves reopened, which we do. And then we're also going to just confirm that pressure is correct. You can see we've got this at about 12 psi, so that is good to go. Our boiler drains are all closed, and our fill valve is also closed, so we don't have that fill valve open anymore. That is closed. So we're ready to restore power to the system and turn the thermostat on inside, which I believe the thermostat is already turned on. So we've got that in the on position. So we just checked. This thing was not coming on. We made sure we had 120 volts coming to the boiler, and then we took our voltage tester. These are the terminals that are fed by that thermostat, and if we test the voltage between them, we can see that we have, there we go, we had 25 volts a second ago, meaning the thermostat was not turned on. And now that the thermostat is turned on, we're reading 0 volts, basically 0 volts between these two terminals. Okay, so the call came from the thermostat. The relay told the boiler that there's a call for heat. The boiler, or the control, then also opened the damper. So the damper's open, and then you heard the boiler start a second ago. If you look down under there, we can see that there is big fire happening. Big fire. And we also heard a bunch of gurgling sounds, indicating that the pump is moving water through the system. So now we will monitor it, and the temperature should come up and up, and we should be able to feel that the water is flowing through the system both in and out and completing the loop. You should never have a spot on your pipe where it's like totally stone cold. If this is stone cold on the return or the supply, then you know that it's not circulating properly. The only additional steps that we may need to take is if there's any kind of air bubbles still stuck in the system, we may have to bleed those out on the radiators themselves. But I don't think we're going to have to do that because we did a pretty good job of getting all of the air bled out of this new pump before we restarted the system. So I don't think we're going to have to do that at all. Now, a lot of times there'll be like a bleeder on top of any high point in the system. So there'll be like a little bleeder right here that you could loosen the cap, an automatic air bleeder, but there's not one on this particular setup. No big deal, but...
What would be the indicators that there's air in the system?
If it stops circulating, or if there's like a whole bunch of gurgling sounds that are happening continually. So we'll know here in a couple minutes whether or not it's circulating based on the temperature of the pipes. We'll be able to feel if it's actually circulating or not. And if it's not circulating, it could be airlocked. And an airlocked system might sound normal, because if this was just full of air right here,
yeah,
it would just be spinning and nothing would happen. If we hear a whole bunch of air bubbles, it just means that, you know, there's more air that needs to be bled out of the system. But like I said, that doesn't look like it's going to be the case. So we'll give it a couple minutes and then we'll do a final update. So the supply side right here and the return side down here are both totally warm, so we're getting good circulation through the system. No significant gurgling or bubbling sounds, so we are good to go. The boiler is all set. Note that your pressure will rise a little bit as the system heats up. That's totally normal. And also the pump running increases the pressure depending on where your pump is in the system. So this pump is pumping down and into the boiler, so while the pump is running, it actually will increase the pressure showing on the gauge by a couple of psi, but still our overall system pressure is right at about 15 psi. One other thing to note is that this relief valve is supposed to be directed to a safe place. Now, it's probably not super hazardous where it's at right here because the likelihood of someone like standing right there is very low, but you have hot boiling water that could potentially spray out of that, and you obviously wouldn't want that to come into contact with a person. So normally you would have a 90 and a piece of pipe that goes down close to the floor, usually within 6 inches of the floor. So that's just something that should probably be added here. Just wanted to note that. One other thing, this is a grease valve, and grease valves are fine when they're new, and they're actually not allowed anymore, but basically what happens with these things is the grease inside of them kind of dries out, and if you turn this valve, it could start to leak. And so if you turn it off and then did some work and then turn it back on again, likely this valve would continue to leak gas, at least in a small amount. So if you ever have to turn one of these things, you also have to replace it. So if we had to shut this off for some reason, we would also be putting in a new ball valve. So just something else to note. You can see that our temperature is coming up nicely here. We're at about 150 degrees. Now once this boiler hits 180 degrees, the boiler itself will shut off. But if there's still a call for heat, the pump will continue to run. So basically, this boiler will run at full bore. It's not variable in the amount of gas that it burns. It's always constant in that regard. So once it hits its cutout temperature here, the boiler will shut down, the pump will keep running. Once the system has used up enough heat, and this drops to whatever that differential is, probably like 170 degrees or something, then our boiler will start again and reheat back up to 180 degrees. Just kind of gives you a little bit of an idea for how these things are designed to work. So the boiler did reach temperature at 180 degrees and shut down. So that's what we confirmed, just to make sure that this thing is operating correctly. And it is turning back on, it looks like now, so only about a 5-degree drop. So the damper just opened, now comes the gas. Alright, that is how you replace a hydronic pump in a boiler system. If you found this to be helpful, hit the thumbs up button, comment down below. If you need a pump for your system, I will put all the links to related materials in the description below. If you want to learn how to use pipe wrenches correctly, you can watch this video right here where I attempt to explain that. You can explain to me why I did it wrong. Sometimes if you get a boiler that's kind of not really working right, the gas will come on and it'll be like this huge flame that goes